Restricted domains. Okay, now we've met this before in some of the exercises that you've just completed. If you're given two graphs here, okay, so this is a quadratic function and this is called f of x, and it's equal to x squared, and x is an element of R, so the domain are all real numbers. And if you take h of x is equal to x squared, and you're given a restricted domain and you're told that x squared is greater than or equal to 0, x values are greater than 0 only. Now, if you look at f of x, okay, it's the function, right, and it's not injective, okay, so it's not an injective function, because if you look for the horizontal line, so it will intersect it at 2 points, okay. So therefore, since it's not injective, then it's also not bijective, okay? Because remember, the condition for bijective is it has to be injective and surjective, okay? So therefore, that particular function, f of x, has no inverse, okay? But looking at h of x, okay, equal to x squared, once you impose the restriction on the domain and you say that all your x values have to be greater than or equal to 0, then what happens is, and you now have a function that's injective, because if you draw your horizontal line across, it intersects the curve at 1 point. You also have a surjective function, because your range and your codomain will be the exact same, and also the horizontal line will intersect at least once. So therefore, once you've injective, once h of x is injective and surjective, it's also referred to as a bijective function. So therefore, we know that all bijective functions have an inverse, okay? So if we take the function y equal to x squared, so x is equal to the square root of y, and if we get f dash of x, which is the square root of x, so that's our inverse for that particular function, or f dash. Now, looking down at this example, okay, it gives a function, and it gives a function with a restricted domain. You're told that the x values are greater than 2. Okay, so you're asked to find f dash of x, okay? So y is equal to x squared minus 4x minus 4. Okay, so looking at that, there's no way where you can get x equal to at the moment. And if you look at that function, this is an example of where you have to complete the square. So y is equal to x squared minus 4x, half the x coefficient, so half minus 4, and you get minus 2, square it, 4, add it on, and then take it away. Okay, so y is equal to x squared minus 4x plus 4 minus 8. So y is equal to x minus 2 by x minus 2 minus 8, or y is equal to x minus 2 all to be squared minus 8. Okay, now we want to isolate x, so y plus 8 is equal to x minus 2 all to be squared. So y, the square root, or plus or minus the square root of y plus 8 is equal to x minus 2, and 2 plus or minus the square root of y plus 8 is equal to x. Okay, now we were specifically told, or we're asked for the inverse first of all, f dash of x, so that's going to be 2 plus or minus the square root of x plus 8. Remember, you just interchange y with x, okay? Now we were told x values greater than 2. Okay, so for x values greater than 2, we have to just use the plus version of this, because if we're taking something away, our values are going to be smaller than 2. So f dash of x is equal to 2 plus the square root of x plus 8. Now in this question, you're also asked to write down the range of the function, okay? So if you're taking x values greater than 2, so say you take 4 or 5 or something here, okay? Then your output values y are always also going to be bigger than 2. So your range is going to be y, which is going to be greater than 2 also.